This video is going to look at Python's ID function. The video will look at the name nature of a Python variable. It will introduce three models that will hopefully allow Python's name nature to be easily visualized. In the main, all high-level languages hide the details of the underlying machine from the programmer. However, before we look at the ID function and the three models, I'm going to give a rough overview of address pointers within the computing machine. Here we can see a simplified schematic diagram of a computer's memory, and we can see we have memory locations following on from each other contiguously. Within here we can see we have contents for a memory location, and here you can see we have the address of a memory location. And down here you can see that these two squiggles indicate that the memory goes on a lot further, but obviously I'm only looking at a small subset of memory locations here. Within an individual memory location you will have a binary pattern. Mostly this will be a binary pattern representing data, but we'll see later that the content can also be storing binary patterns that represent other things, such as a memory location address, and we'll come back to that a little bit later. Clearly, this is a binary pattern representing the address of the memory location that has the appropriate content. When we look at a computer's memory and we think of a high-level language program, when we declare variables, they get stored in the computer's memory somewhere. And as a high-level language programmer, we're not usually worried about where they get stored. They just happen to be stored in a location that allows the program to function. But it is feasible that a variable can take up more than one memory location. And here we can see that the variable has gone across 4 contiguous memory locations, in which case this will be the first address of the variable. The variable therefore can be identified by this first address. Now, how long the variable is in terms of the number of locations, I'm not going to worry too much about that at this particular point. But what we can say is that this first address here dictates that, well, the variable starts at this point. Of course, this could be the address of the next variable, and the next variable might only actually take up 2 memory locations. But this variable, whatever it is identified by this particular address here. Let's consider this schematic diagram of a computer's memory, and let's say we now have a program that produces a variable, and the binary pattern for that variable is too big to go in one memory location, so we can see that it goes across 4 memory locations. Now, bearing in mind what we've just been looking at, this now will be the first address of the variable data. So this will be the first address where we get the first bit of the binary pattern that represents the value of the variable, and the following locations, as we can see surrounded by the red box, represent the remaining parts of the binary pattern, and when all this is combined together it gives us the value that's stored in the particular variable. But it's possible for us to put this first address, which after all is just a binary pattern, in its own memory location, as you can see here. Now, if that's in its own memory location, then this is the address of the pointer to the data. Now, what does that mean? Well, it means that this location holds a binary pattern which is not going to be data, but it's going to be an address, and this address points to where the actual variable is stored in the computer's memory. Here we can see a simplified schematic diagram of a microprocessor system, if you like, a computer system. We can see we have a central processing unit, an address bus, a data bus, and inside the CPU we have address registers and we have data registers. Now, I want to concentrate here on the address registers. A register will hold a binary pattern regardless as to whether it is an address register or whether it's a data register. But let's say inside here we have a binary pattern. That binary pattern is placed on the address bus. It goes from the address bus to the memory and selects a specific memory location. And in that memory location there could be a bit of data that's then brought in via the data bus, put in the data register, and is processed in some way. So the binary pattern that was in here, in fact, was the pattern that located inside the memory where the data is, and that pattern would be the address of the specific memory location. So what we can see here, we have this notion of address registers pointing to locations where you will find the data to be manipulated. When we looked a moment ago at the computer's memory, we also had this notion of a location holding a binary pattern, where that binary pattern was actually an address that pointed to another location. So we have this concept of pointers, which is quite important in computing. It's not possible to relate what we've just looked at directly to Python, but it is possible to say that the notion of a pointer to a variable is important in Python, as it is in all programming languages. And the purpose of those schematic diagrams was just to try and fill in some background if you didn't know what actually happens down there at the machine level of a computer. Let's now consider the Python programming language. Here we can see a pretty straightforward program where a is assigned 7, and then we simply print the value of a. So we will get this here, and you can see that it prints 7, which is clearly the value of the variable a. If we have a look at this program, well, we've looked at this particular function before, type, and here you can see to type we're passing in a, and then we're printing what type returns, and type returns this here. And we can see that it clearly shows us that a is of type int. Now the fact that this has got the word class here, well, you need to refer to the previous video to remind you of what a class is. But as far as we're concerned, in this video, a class and type are synonymous with one another, they're one and the same. If we now have a look at this program, this is where we introduce the ID function. And here you can see I'm saying let a be assigned 7, and here the ID is past the a, and the ID will return something, and that something is then printed. And what we get printed is this here. And you can see we get this large number. Now this number is not the value of a, the value of a is 7. What this is, it's a unique identifier which identifies the variable a. And that's what I want to say about it at this point. It is a unique number. That's the identifier of the variable a. Let's consider this program here. Here we can see a has been assigned 7 and b has been assigned 56, and then we print a and b with these two statements, and then we print the ID of a and b with these two statements here. So when we run the program, we get this. So let's look at this statement here, print a. When that executes, we print 7. When this executes, you can see we print 56. When this executes, we're going to print the ID of a, and we get this number, which is the unique identifier for the variable a. When we now print the ID of b, we get this, which is the unique identifier for variable b. And if you look at these two, you can see they're different. They're different identifiers because they're clearly different variables. Now let's have a look at this one. Here you can see I've let a be assigned 7 and b be assigned 7. Now let's have a look at what happens when we go through the print statements. Well, here's the runtime. Now let's have a go at this one, print a. And we should expect it to print 7 because that's the value of a, 7. And we can see it does, it prints 7. This one, when we print b, well, b is also assigned 7, so we would expect that to be 7, and we can see it is. Now here we print the ID of a, and it prints this number here, 1477492232. That's the unique identifier for the variable a. Now when we come on to here, it's going to print the ID of b, and let's see what we get printed. We get this. Now if you look very carefully, you can see these are the same. So what's going on here? These are different variables, but we can see they have the same ID. And I thought we were supposed to have these ID being unique to each variable. Well, it's the way in which Python produces its variables that results in the ID of A and the ID of B being exactly the same in this particular case. Before we try and explain what happens with the program we've just looked at, let's take a step backwards and look at a slightly simpler program, which is this one here, where A is assigned 7, and then we print A, and then we print the ID of A. And when the program runs, you can see we have the 7, which is the value of A being printed, and then we print the ID of A, which you can see is this long number here. Now, when we go and have a look at this particular program statement, A is assigned 7, I like to think of an execution space in which everything executes. This is where all the data is put, this is where all the variables are, and this is where we do all of our processing. So when we say A is assigned 7, two things happen. What we get this rectangular shape in the execution space, and we get this circular shape in the execution space. Now the circular shape is going to be an object. It's going to be an object that takes the value of A, which is 7, so we store 7 in there. Now the rectangular shape is going to hold the ID of the variable A, which is shown here. Now this particular ID is the unique identifier for the variable A, and it points to the object that holds the 7, and we say these two are bound together. And in fact all of this is regarded as A. So A is not just a simple box in Python with a number in, it's a little bit more involved. It has this unique identifier, and it also has somewhere else where it stores the value. If we now have a look at the Python help, it says this: every object has an identity, a type, and a value. An object's identity never changes once it has been created. You may think of it as the object's address in memory. Now I want you to concentrate on those first two sentences there. Then go down to where it says C Python implementation detail. For C Python, ID bracket X is the memory address where X is stored. Now hopefully you can see why I introduced the notion of pointers right at the very beginning of this particular video. If we now consider this particular ID, I think it's fair to say that this is the address of where the value of the variable is stored. Now I don't think we should wonder how these two relationships get stored, what the data structure is inside Python to allow for this binding of these two together. But I think it's important that you have some kind of model as to what's going on under the hood of Python, and I think this is as good as any. Let's now consider this program here. The first program statement is A is assigned 7. So let's have a look at this modeled with our view of the execution space. Well, here is the execution space, and because we're saying that A assigned 7, we will get this relationship occurring. We get the rectangular area and we get the circular area. Now the circular area is going to hold the value of 7, as you can see here, and the rectangular area is going to hold the ID of A, which we can see is this value here. And of course this now points, and it points to the object that contains the value of 7, and we say these two are bound together. Now all of this is now regarded as being the variable A. If we now go on to have a look at this statement, B is assigned 56, something similar will happen, and the something similar is we have a rectangular area produced and we have the circular area. Now of course the circular area is going to hold the value of 56, as you can see here. Now this will hold the unique identifier for the variable B, so this here will actually point to the object that contains the value 56, and we say they are bound together. Now all of this represents the variable B, and of course this is just a model of the variables as they appear in this notion of an execution space that I have introduced. So when the program actually executes, we get this output here. So let's have a look how this is actually achieved reference to the model we've used. When we print A, we're actually going to be printing this value here. When we go on to this one, when we print B, we're actually printing this value here. Now when we print the ID of A, we're actually printing this value, as you can see it's appearing here. When we print the ID of B, well, we're actually printing this value, as you can see it appears here. Let's now consider this computer program here. Now when this executes, we will get this particular output. Let's concentrate on this assignment statement here. A is assigned 7. Now when this executes, the execution space will look as follows. It'll have the rectangular area and the circular area, and of course the circular area will get the value of 7, as you can see appearing in the center of the circle. And of course the rectangular area will receive this ID, and this ID will point to the object that contains the value of 7, and we say these are bound together. And of course all of this is now the variable A, and we have this relationship between the ID and the value. If we now come on to this, which is B is assigned 7, what Python now does is says, well look, I've already got an object with 7 in, I've already got this circle, I'm not going to create another object with that value, I'm not going to chew up some memory space because I've already got that particular value here. So what it does, it creates a rectangular area, and into this rectangular area it takes this ID here and puts it into this particular rectangular area. It copies the reference across, it copies the ID across, and of course this ID now points to the object that already exists. So these are now bound, and all of this is now regarded as B. So when we come to print A, what we're printing is this value 7 as it appears here. Then we go to print B, and of course it references the same object, so this 7 is put here. When we print the ID of A, then of course we're printing this value as it appears here. Now when we print the ID of B, we're printing this value, which we can see is the same as this value, and of course that gets printed here. So here we have another model that shows us, well look, if I've got an object that's got 7 in, and I assign this 7 to something else, I'm not going to create another object in the memory, I'm going to reference it. So A and B reference the same value, the same object. Here we can see the same program and we will get the same output. What I'm going to do now, however, I'm going to use the execution space, but I'm going to model this program slightly differently. Here you can see the execution space, and when I now execute A is assigned 7, then I will get this relationship occurring. I will have the 7 appearing in the circular shape, and I will have the ID, which is this here, appearing in the rectangular shape, and of course that will point to the 7, and these will be bound together. And of course all of this is now the variable for A, and we have this relationship between the ID and the actual value that's stored in the variable A. When I now go on to this, where it says B is assigned 7, then we've already seen in the previous modeling of this program that the 7 already exists. Look, it is here. So what we can say occurs is that this also gets the label B. So all of this now represents B. So it's a slightly different model, but it's up to you which one you prefer. I'm going to show you a third one in a moment. But when we now execute this particular program, when we print A, then of course we're going to be printing this value as it appears here. When we print B, then we're going to be printing this value here. When we now print the ID of A, well, we can see that this is the label A, which has this identifier, and it's consequently this identifier that is printed here. And when I now print the ID of B, well, we can see this is also labeled B. So we print this value, as you can see here. So these two IDs are the same. And that's because I've made the A and the B both assigned 7. So the object existed when it came time for the B to be assigned the 7, so it used the same object that already existed in the execution space. At the beginning of the video, I indicated that I was going to show 3 models for this particular assigning of values to variables, and to show the relationship between the ID and the value of a particular variable. To keep this video at a reasonable length, I'm actually going to show you the third model in the next video in the series. Check out the supporting website for these videos, and also consider subscribing to the YouTube channel and get an automatic update every time I upload a new video. Also consider subscribing to the Google Plus circle that relates to these videos.